Assalamu alaikum and welcome back to the ITV Math Show. We ended up our first segment before the ad break with cyclic quadrilaterals. We now did and circle geometry. We did example number 4. We gave you a diagram here and we told you to solve for x, y and z. We are busy with graded set of riders. So guys, I told you guys, no homework during the break. So we're now going to go on to example number 5. We're going to choose a different example. So get ready, get your pens and papers and your books ready and start taking down the diagram with me. So as I take down the diagram, I want you guys to take it down with me. So let's start and let's see what do we have. Right, we're now doing example number 5. Okay, let's take the diagram down. There's a circle. We've got O being the center of the circle as usual. We've got a line going down this way. We've got a line going down that way. And we've got 2 radii, so we already know we've got 2 radii. And then we've got a line joining those 2. So we've basically got a triangle there. We've also got a tangent passing here. So there's a tangent passing at that point and continuing this way. We've also got a line going up that way. And we've got it joined here. So let's just take that down better. And that's it. Now let's start labeling. We've got S, we've got that line parallel to that line. So the minute we're doing this, and like I said, as you are drawing your diagram, you're already identifying your theorems. So we've got a tangent, so we know tan chord theorem. We've got parallel lines, we know we're going to be using alternate angles, corresponding angles, or co-interior angles. We've got radii, so we know we're going to be using isosceles triangle. We've got the spearhead. Remember the spearhead? Exterior angle at the center is equal to 2 times angle at the circumference. So just by us redrawing the shape, we're already picking up all the theorems that are going to be utilized to get to our answer. Okay, we've got Q, we've got T, we've got YW1X, YW1X. We've got this as 140 degrees. We've got P. And we've got R, we've got Z and 1. We've got R, we've got Z, and we've got 1. So we've got X, W, X, Y, Z. You're not required to find. So basically, what are you required to find? You are required, let's just underline that. We are required to find W, X, Y, Z. Total marks, 7 marks. Okay, hope you guys have taken this diagram down. There isn't anything else that is important. All they tell us that ST is a tangent. Now the minute they tell you that it's a tangent, you know you're going to be using tan chord theorem. It's a given. What are your rules with regard to a tangent? Number 1, you got tan chord theorem. Which other rule can you think of that utilizes the tangent or that the tangent is in that rule? Line drawn from a center of a circle to a tangent. Yes, or a diameter or a radius meets a tangent at 90 degrees. So do we have a radius? Yes, we do. So we already know that this whole angle here, line drawn from center of the circle to a tangent, we already know that that whole angle there is 90 degrees. Okay? Now, let's start. We said we start with our known. So we're starting with 140. We know that OQR, triangle OQR is isosceles. Why? OQ is equal to OR. Although it's not given in the problem, but you are doing it by inference. How did you get it? You know that OQ is a radius, OR is a radius, therefore radii are equal in length. So the first thing we're going to do is to prove this to be. You can never in the exam, yes it looks, you can't, to you, immediately the first thing that comes to your mind is, yes, that's an isosceles triangle, so I'm going to write it as a reason. You'll get it wrong. You first got to prove it. Listen to what I'm telling you guys. You need to first prove it to be isosceles before you can then utilize isosceles as a statement in your justification.